Morning, everyone. My name is Vasily Sartakov. Our presentation is project also slightly different from others because it solely rely on Cherry. I will give you a talk about the Intravisor and the project with that. There are two key approaches for virtualization. The hardware virtualization, when we have hypervisor. Okay, we have hypervisor and we have virtual machines. This approach for virtualization offers very strong isolation of virtual machines. Virtual machine wants to communicate with the other one. It must use hardware abstractions, and it leads to very slow IPC. The other approach is to use the kernel. It's containers or namespace virtualization. In this case, your process or your programs or services exist in virtual environment. It assumes they exist solely or uniquely in the system. However, in fact, the kernel is shared between all components of the system, and your REST API application, in essence, has the USB driver, for example, in the trusted computing base, which is slightly wrong. And we propose the third design. We use hardware memory capabilities for isolation and sharing. And our shared trusted computing base is extremely small, similar to hypervisor. It can be a small verified microkernel, and we don't share the namespace. Our VMs don't share namespace, and the IPC mechanisms we use also quite fast because we use Cherry capabilities for IPC. So what is the Intravisor? Intravisor is some sort of type 3 hypervisor that it uses its own address space to isolate and sharing capability-based VM. So in essence, it's a compartment with some binary inside, and those compartments interact each other using capabilities without the involvement of the shared intermediary, the kernel in our case. We support two architectures, RISC-V and ARM. We support hybrid and pure APIs. In essence, in the case of hybrid API, you can literally take the Docker image from ARM on RISC-V, export it, and run on top of our infrastructure using capability-based IPC mechanisms hidden behind the POSIX APC primitives. In the case of PureCape software, we offer PureCape library operating system and several applications ported to this environment. So you can really take all benefits of Cherry, such as special memory protection, lightweight isolation, and fast IPC. As a part of the Technology Access Program Cohort 4, we extended the Intravisor project by the cloud orchestration mechanisms. So what is it, cloud orchestration mechanisms? In the clouds are based on, obviously, hypervisors, but they become cloud only when those hypervisors are remotely managed by the cloud orchestration software. Cloud orchestration software allocates virtual machines, deploys them, performs provisioning, migration, resource management, and so on and so forth. And the technical side, it looks as follows. There is the orchestration server on the left side and the VM host on the right side. And on the host side, there is a process, Libvirt, in our case. There are many solutions for that. And this process takes assignments from the orchestration server. So this XML request by TCP IP, as you can see in this figure. And we want to integrate this with Intravisor to make orchestration capability, to add orchestration capability to our Intravisor. There are many approaches how to do this. The simplest approach is to use the simple design of Libvirt. Libvirt is a process. Intravisor is also process. Libvirt can spawn process of Intravisor on request. However, it's not practical in terms of use of capabilities and similar things. Our approach is the fourth one in this figure. So we can run Libvirt process as a standalone CAP VM. So it's some sort of eat your own dog's food. Eat your own dog's food. That's what we did the part of this project. So how we did this? We ported Libvirt to infrastructure provided by Intravisor that requires minimal extension of the library operating system and muscle runtime we use in our projects. We ported dependencies such as GNU-lib, libxml2, trpc-xdr, and Libvirt also was ported, obviously, and we also extended the host call interface between Libvirt and Intravisor. In our PureCap environment, we use TCP/IP stack provided by the host operating system, but someday it will be changed, I hope. As the target VM, so the VM we want to deploy on request, we used Redis. It was ported previously during another project. This is the demo, how it works. On the left side, you can see our orchestration server with Virsh utility, and the right side, we see Libvirt Cap VM. So Virsh will communicate with Libvirt and provide a configuration file of the Cap VM we want to spawn. Libvirt will interact with Intravisor, ask Intravisor to spawn this Redis Cap VM, and then we will benchmark our Redis Cap VM by Redis benchmark utility executed on the orchestration server. Okay, so now it's a demo in the form of screenshots. The right side is this configuration file of with Redis XML. So this file will be sent by Virsh from orchestration server to the Intravisor Cap VM. Left side is a configuration file with Libvirt Cap VM. We spawn them, and left side successfully booted, and the right side we want to connect to the Libvirt Cap VM using the Virsh utility. The right side shows the way how to do this. It says it's a Cap VM protocol plus TCP/IP. Successfully connected, and now we want to create a Cap VM with Redis inside, providing the XML configuration you can see on the right side of the screen. The left side says that Redis is ready to work, and we can now benchmark it using the Redis benchmark utility. We will send 1,000 set and get requests, and this is the result. Left side, a lot of debug. The right side, performance metrics generated by the Redis benchmark utility. Now, let's check that Virsh, in fact, is aware that the Cap VM that it's running. It says it's running. Now, let's recap. In Intravisor is a type 3 hypervisor that uses hardware memory capabilities for isolation and sharing. As part of this program, we integrated Libvirt. It's a cloud orchestration software with our Intravisor. Generally speaking, Intravisor works not only for cloud workload, but will work for embedded systems. And I will be happy to answer your question. It's an open source project. You can find it in GitHub, and write me emails if you have any questions. Thank you very much.
Vasily, thank you. Thank you very much. Any questions for Vasily at all? Any questions, anybody? Vasily, I had one question for you, if I may. I'm not going to let you escape that easily. When you were doing your work and kind of getting the hypervisor and the virtual machines and everything kind of up and running, were you able to test whether there was any, I guess my question is really, were you able to test any kind of security elements of them? Is that something that you're able to do, or is that something that you might do going forward?
The short answer, no. The long answer, we have, as I said once, a small set of integrity tests. So we will run them some time to time to ensure that our Cap VMs provide security guarantees, such as isolation, and we don't go outside the borders. So we didn't find any bugs in Libvirt, if you're interested in this part.
Thank you.